Hello friends, today at the request of some of my subscribers, the Ohm's law is on the circuit section. This is a simple and at the same time interesting topic that need to be understood correctly. When I was at school, the teacher wrote this law on the blackboard like this. The current range I is equal to the voltage U divided by the resistance R. I think most people understand this, and it would seem that there is nothing complicated here. This is not quite true. Try to express the resistance from this formula and ask your students or yourself a question. What does the resistance of the conductor depend on? What kind of response do you plan to get? If you know a little mathematics, then in mathematical language the resistance of a conductor depends on the voltage and current range. In fact, this is not the case. The resistance of the conductor does not depend on either their current range or their voltage. This is the difference between physics and mathematics. Physics is even more complicated. Isn't it right? But let's figure it out. Why, after all, the resistance of the conductor does not depend on either the current range or the voltage. It's all about Ohm's law, which is incorrectly interpreted by methodologists in physics. Let's try to figure it out. Ohm assembled the simplest circuit from a resistor, voltmeter and ammeter. Of course, there is a current circuit somewhere else which is not yet considered here. While I'm drawing slowly, but get used to it, I'll do it faster each time. So there is a voltmeter and ammeter and some conductor. I hope you know how to connect an ammeter and a voltmeter in an electrical circuit. The voltmeter has a large internal resistance and is always connected in parallel, and the ammeter must have a very small resistance and is connected to the circuit in series. If you want to learn more about this, about how to connect an ammeter and a voltmeter, then write about it in the comments. Let's go back to our topic and see what Ohm was doing. The ohms measured the current and voltage. Ohm made several experiments and made sure that the ratio of current to voltage is a constant value. This means that how many times the voltage increases, the current range increases by the same number of times. Thus, the ohm received a certain constant value which does not depend on either the current range or the voltage. Ohm called this value conductivity. Once again, I draw your attention to the fact that this constant value does not depend on the current range or voltage. The conductivity is measured in Siemens. Remember? There was once such a phone. I don't know where he is anymore. If you divide the unit by the conductivity, you get a new physical quantity called resistance. I think the letter R is already familiar to you. Mathematicians use this letter in most cases to denote radius, and physicists denote resistance. Thus, the resistance is measured in ohms. Ohms and Siemens are reciprocal physical quantities. If you know the resistance, it immediately find the conductivity. Divide the unit by the conductivity and you get the resistance. But the question arises in voluntarity, and what does the resistance of the conductor depend? To answer this question, you need to know that a metal or a conductor of the first kind is a crystal lattice. It is natural to assume that the longer the conductor, the greater its resistance. The larger the cross-section area, the smaller the resistance. This is due to the fact that valence electrons are free charge carriers in metals. They are weakly bound to the nucleus of an atom, therefore they participate in electrical conductivity. If the conductor is thick, then it is easier for electrons to move along it. I started drawing a little faster. In the nodes of the crystal lattice there are positive metal ions that make thermal vibration. It is the thermal vibration of the lattice that prevents the directional movement of electrons. This is the physical essence of resistance. If you want to learn more about how the resistance of conductor depends on temperature, then write about it in the comments. Thus, once again, I want to draw your attention to the fact that resistance is a consequence of the vibration of the crystal lattice. I also want to note the fact that in addition to the length and cross-section area, the conductor material itself must be taken into account. The value that characterizes the type of conductor is called resistivity and is denoted by such a symbol as the density of matter. If you want to know what the resistivity is, then you should take a cube of material with an edge length of 1 meter and measure its resistance. Thus, the resistance of this cube is equal to the resistivity. That's all for now. I invite you to follow my Telegram channel by the link that I will leave in the description of this video in the comments. I also invite you to visit the clothing store of People of Science by the link then I will leave in comments. All bye. Sincerely, Yuri Kovalyanak.